Lesson 10.2 is compound interest, annuities, and amortization. So back in chapter 5, we talked about simple interest, which is interest that remains the same every year. So for example, I'm going to borrow $1,000 at 5% of simple interest. So every year you pay 5% on that original $1,000. That's not the most real-world situation. Most of the time interest is compound interest, which means the interest is being added to the original amount and the interest builds on itself. So for example, a regular savings account, when you open it up, you put money in. At the end of the month, they give you interest. The next month, if you don't touch the account at all, don't put anything extra in it, you'll earn interest on whatever's in the account, which is the original amount you put in plus the interest you earned on the last month. So that interest is building interest. Compounding periods is how often you earn interest. So the most common are annually, once a year, biannually, twice a year, quarterly, 4 times a year, or monthly, 12 times a year. The formula for compound interest is that the future value, so what you're ending up with, is equal to the present value, what you start with, times 1 plus your interest rate in not decimal form, divided by 100 times k to the kn power, where k is the number of times a year it's compounding, so how often you're earning interest, and n is the number of years. So for this first example, it says that Peter invests 2,000 Australian dollars in a bank that offers simple interest at a rate of 3% per annum or per year. Paul invests 2,000 Australian dollars in a bank that offers 2.9% interest compounded annually. So we want to calculate how much money they're each going to have in the bank after 10 years, and then determine how many years it will take for each of them to have at least $5,000 in the bank. So the first one has simple interest, and the second one has compound interest. So go ahead and pause the video and calculate those. So for Peter, he is simple interest. So simple interest is how much total you started with, your principal value, plus the interest earned, which is the initial value times the interest rate times how many every years. So you end up with 2,000 plus 2,000 times 0.03 times 10, so he ends up with 2,600 Australian dollars. Paul has compounded 1 time a year compounded interest. So we're looking for his future value. His present value is 2,000. His interest rate is 2.9. K is how many times a year it's compounding, which is annually, so 1 time a year. And then N is how many years, so 10. Plug this in your calculator and you end up with, in Australian dollars, $2,661.85. You can also solve these with the TVM Solver app on your graphing calculator. So if you go into Apps, which is kind of cat-a-corner to the alpha button, and then number 1 is Finance, number 1 is TVM Solver. So you go in there, and then it gives you a list of things to fill in. So N is the number of time periods, usually years. I is your interest rate in not decimal form and in percentage form. PV is your principal value, so same thing here. But whenever you're doing these, you always need to enter it as a negative number because it needs to be the opposite sign of your future value. Payment is, or PMT is your payment, so if you're adding money every year, we'll talk about this a little bit later on. FV is your future value, so what you want to end with. P/Y is the payments per year, so like if you're putting in money, how many times a year are you putting in money? C/Y is how many compounded times a year, so in this case it would be 1. And then whichever one you're solving for, you move your cursor to that one and hit alpha enter, which is solve. So for this one, you would put PV to be negative 2,000. You would have I be 2.9. The compounding per year would be 1. And the number of years would be 10. And then payment, you would just leave that as 0. And payment per year, you can just leave that as 1. So then you would scroll down to future value and hit alpha enter. And it should tell you what this number here. And then same thing with part B, we want to figure out how much money or how many years until they have 5,000 Australian dollars. So for Peter, I just set this equal to 5,000 with, instead of 10, this being N, and solve. So I subtracted 2,000 from both sides and then divided by 2,000 times 0.03. And after 50 years, he would have $5,000. Paul, you take this, and there's a couple ways you can do it. If you remember your logarithms, you can use logarithms. We'll talk about that a little bit at the end of the chapter. You could also use the y equals and set the two equations equal to each other and use the intersect function on the graphing calculator. Or you can use your app. And so you would plug in, N would be your unknown, so you don't know anything for that. I would be 2.9. Your principal value is still negative 2,000. Payment is still 0. Future value would be 5,000. Payments per year and compounding per year would still be 1. And then you would go up to N and you'd hit alpha enter. And it'll give you 32.05, but you're only earning interest at the end of every year or once a year, so therefore it would take 33 years. For this next example, Rafael invests 5,000 Brazilian real in a bank offering 2.5% interest compounded annually. We want to calculate the amount of money that he has after 5 years, and then he's going to take all of that money out of the bank and he's going to put it into another bank that offers 2.5% interest per annum, so per year, compounded monthly. And then we want to calculate how much money he's going to have after 3 more years. So how much money is he going to have after 5 years in the first bank, and then take that out, put it into the second bank, how much money is he going to have after 3 more years. So go ahead and pause the video and try this one. So for the first part, he's going to take his principal value of 5,000, an interest rate of 2.5, compounded 1 time a year, and for 5 years. Plug that in your calculator, you end up with he'll have 5,657.04 Brazilian real. So then he's going to take that, and that's going to become his new future value with an interest rate of still 2.5, but this time K is 12 because it's compounded monthly, 12 times a year. So that's why K is 12. And then for 3 years, plug all that in, he'll end up with 6,097.16 Brazilian real. Also, if you use the TVM solver, N for the first part would be 5, I would be 2.5, PV would be negative 5,000, and C/Y would be 1. Highlight the future value, hit alpha enter, and it should give you this value. And then for the second part, part B, N would be 3, I would still be 2.5, PV would be negative 5,657.04, C/Y would be 12, and then go to future value and hit alpha enter. And also on the IB exam, this is an acceptable version of your work. It's equivalent to writing out this. So for the next example, Alexis invests 80,000 Russian rubles in a bank that offers interest at 3% per annum compounded quarterly. We want to calculate how much money Alexis has in the bank after 6 years, and then calculate how long it takes for his original amount of money to double. So go ahead and pause the video and try number 3. So for the second example, the future value for part A, the present value is 80,000. We're solving for the future value. The interest rate is 3. It's compounded 4 times a year, so K is 4, and for 6 years, N is 6. Or if you wrote it in calculator form, N would be 6, I would be 3, your present value would be negative 80,000, payment would be 0, future value, that's what we're solving for. Payments per year, just leave it at 1, and then compounding per year is 4. Go to future value, hit alpha enter, and you should end up with 95,713.08 Russian rubles. For part B, calculate how long it takes for his original amount to double, which means we want to end up with $160,000, rubles, and then either solve this by hand with logarithms, or using y equals, y1 is one of the sides, y2 is the other, find where they intersect, or use your app, N is your unknown, and then I is 3 still, principal value is still negative 80,000, future value is 160,000, compounding per year is 4, go to N, hit alpha enter, and you end up with 23.2 years, but you're only earning interest every quarter, so this is slightly less than 1 quarter, so basically 23 years, and after the first quarter or 3 months, that's when he'll have his money doubled. Another important piece of financial math is inflation. So inflation is the rate that prices of goods increase over time, and basically how much less your money can buy. Inflation adjustment is the change in price of an article that is a direct result of inflation, so raising the price to counteract the inflation, basically. So if the inflation rate of a country was calculated at 4.48% per annum per year, given that the same rate continues for the next 5 years, work out the percentage increase due to inflation at the end of the 5 years. And then for part B, if a computer game costs $35 today, calculate how much you would expect it to cost the next year due to an inflation adjustment at that same inflation rate. So go ahead and pause the video and try this inflation example. So if this is repeating the same percentage increase every year for 5 years, that's repeated multiplication. So I took our rate of increase, 1.0448, and I raised it to the 5th power because it's going to increase by that amount every year for 5 consecutive years. And so you end up with 1.245, or an increase of 24.5%. For part B, if you have a game worth $35 today, then if it's increasing by 4.48%, I multiplied it by 1.0448, and next year you would expect it to cost $36.57. The next part of financial math is annuities. So an annuity is a fixed sum payable at specific intervals over a period of time. So for examples of this would be like if you are saving money for retirement, or if you have, like, you paid a premium, so then you're going to earn a certain amount of money every month, like there's an account and it pays you out every month, something like that. An example would be like this one down here. So Abraham wants to save up money so he can retire early. He decides to save $5,000 every year in an annuity that pays 4% interest compounded annually. So if he wants to retire in 20 years, how much money will he have in the annuity at the end of the 20 years? So he's paying in every year, he's paying $5,000, and then it's earning 4% interest. So the first year he pays $5,000, he earns 4% interest, now he has $5,200. So then he adds another $5,000, that earns 4% interest, and so on and so forth. So at the end of the 20 years, he ends up with $154,846.01. As opposed to if he just kind of put away $5,000 every year into something that wasn't earning any interest at all, he would only have $100,000. So basically he's earned almost $55,000 just in interest. This is the formula for it, so FV is your future value, A is the amount invested every year, N is the number of years, and R is the interest rate. But you're not expected to know this. You're expected to use your TVM solver on your graphing calculator. So in this first example, Anmal decides to save for a yacht, and he would like to have 1 million Turkish lira at the end of 10 years. He saves each year in an annuity that pays 4% interest, and he needs to figure out how much he needs to save every year to get to that point. So if you use your TVM solver, you're going to have the number of years be 10, the interest rate is 4. The principal value is 0. He starts with no money. That's what he's saving for. The payment is what we're going to solve for. The future value is $1 million. Payment per year is 1, and compounding per year is also 1. So then you're going to go to, bring your cursor over to payment, hit alpha enter. And once you've done that, you find that he should be saving 83,290.94 Turkish lira every single year. So in this next example, it says Trinjay has been left an annuity of 5,000 euro in a will, and the annuity is for 5 years at 8% per annum to be paid out monthly, and we want to find the monthly payments. So basically in the will there's 5,000 euro, and it's going to pay her a certain amount of money every month for 5 years until the money's all gone. And so then we want to figure out how much she's actually going to be getting every single month. One key part on your annuities is, even though this was kind of always been in years, this is compounding per year, payments per year, we actually want it to be in whatever time unit is the payments. So if your payments are going to be in months, we actually want everything to be in months. So this is something that's a little bit tricky to remember, because these say payments per year, you think that they should be the actual payments per year, but you actually want it to be in whatever time period the payments are in. So if the payments are in monthly, you want to think of all of this as per month. So N is 5 years, but because we're paying, or she's getting paid every month, it's actually 5 times 12 because it's 60 months. The interest rate is 8% per year, but again, it's being paid out monthly, so the interest rate per month is 8 divided by 12. The present value is still 5,000. Payment is what we're going to solve for. The future value is 0 because they're paying off the 5,000, so it's going from 5,000 to 0. Payments per year is really payments per time period, and since we're thinking about this as monthly, the payments per time period is going to be 1, and then compounding per time period is going to be 1 as well. So then you're going to go into your TVM solver, you're going to enter all of this, and you're going to go to payment, and you're going to hit alpha enter, and she will be getting 101 euros and 38 euro cents every single month. So the key part is whatever time period your payments are in, you want everything else to match the same time period. So N should be how many of those months or years or whatever the time period is. The interest rate should be in whatever that time period is. So just keep that in mind when you're doing these. The last part of a financial math section is amortization. Amortization is similar to annuity, but the value of the item is decreasing each term, like paying off a loan. So the interest is something you owe, but the amount of money you owe is decreasing. So this is the formula for it. The payments A is equal to the present value, R is your interest rate, N is the number of time periods. But you're not expected to know that, you're expected to use your TVM solver. So here's an example. Pim borrows $1,000 from a bank that charges 4% interest compounded annually. He wants to pay the loan back in 6 months in monthly installments. The bank informs him that he must pay $168.62 every month. So here's a table that basically shows what's happening. So the first month he owes $1,000 and his payment is going to be $168.62. Well, first he has to owe interest on that $1,000. So the annual interest is 4%, but he's paying it back monthly, so his monthly interest is 4 divided by 12%, or like 0.333%. So on the $1,000, he's going to owe $30.33. So his payment, only $165.29, is actually going to go to the principal value of his loan. So he has to pay the interest back first. So that's why it doesn't completely decrease by the full amount. So then that comes off the loan. So now for the second month, that's how much he owes. He has the same payment, and then his interest rate's the same, but because the loan now is a little bit smaller, the amount he owes is a little bit smaller, which means the amount that's going to the initial value is going to get a little bit bigger. And so that happens every single year, every month. The amount of interest he owes is going to get smaller and smaller, so the amount of his payment that's going to the actual loan itself is going to get bigger and bigger until he ends up paying off his whole loan. So this is like how mortgages work and stuff. For the first over half of a mortgage, pretty much your entire payment is just going to paying off interest. It's very little that actually goes to the original amount of the mortgage itself. So in this example, Tejas is taking out a car payment loan of 35,000 euros, and the loan is for 10 years at 1% interest per month. So notice that the interest rate is already a monthly interest rate. We want to find out how much he has to pay every month. So we're looking to solve for his payments. So if we plug all this into our TVM solver, N is going to be 120 because in 10 years there's 120 months. I is already in monthly, so our interest rate is just going to be 1. Our present value is 35,000. Our payment is what we're solving for. Our future value is 0 because we want to pay off the whole loan. Payments per time period is 1, and compounding per time period is 1. So go ahead and solve for his payments per month. So using the TVM solver, highlight payment, alpha enter, and his payment is going to be 502 euros and 15 euro cents every single month. Just like your annuities, when you're doing your amortizations, make sure your time periods always match the payments. So if your payments are in months, make sure N and I, those are in months as well. So this has been financial math. We talked about compound interest, we talked about annuities, and we talked about amortizations.